So I think we're going to move on to the next session. So this session will feature representatives from core facilities who will showcase their ways in interacting with companies. We have the pleasure to have Greg and Jans here, who I invite to join. First will be Gregory and then Jans, sorry. So both of them have a long experience in dealing with private companies in different ways. Greg is, well, he's originally from Texas. I just learned that he did his first electron microscopy experiment 50 years ago this year. And after that, he did a long academic and successful career. He's now in Brazil for more than 27 years, and so he's half Brazilian already. And he's now the director of the Center of Microscopy at the Universidade Federal de Minas Gerais. And that center has a very strong interaction with industry. He will tell us about that. We hope to learn a lot about these two people. Jan, on the other hand, has a long story of working in, and successful also story of working in big companies like Novartis, Zeiss, Thermo Fisher, and different aspects of microscopy. So he has a very, very fruitful story working in companies. And now he's in Fiocruz working in, so he will tell us about all his experience. I think this is a very, very challenging topic for us in Latin America because we still are far away from the private funding for science and technology compared to other countries. And so how are we going to do to strengthen those ties between academia and industry? It's still a challenge for us. And for LABI, it's very important to understand how we can build this kind of relationships with industry partners. So welcome, Greg. Thank you very much.
No.
Timer?
Okay. Yeah, I was going to, but let's see. So 50 years in electron microscopy, so I've made every mistake at least twice. So if you look at the map here, you can see the little red arrow is pointed at Belo Horizonte. That's where I'm from. It's a city of about 6 million people. The state of Minas Gerais, I always tell people, some of you have heard this, Minas Gerais is a little bit larger than France, and it's a little bit smaller than Texas. Everything has to be based on my vision of Texas. Rio de Janeiro, on the other hand, is just a little bit bigger than Switzerland, so that means Texas is bigger than Rio de Janeiro. So the other point I want to make here, important, is if you look at Minas, it's a large state. There are 11 federal universities, a couple of other institutes there, so we have a big academic usage. That's federal universities that are present. And so I think there are 60 research institutions in the state. But also the name Minas Gerais is general mines. And so we have a huge, huge mining industry in the state, and that will be part of a lot of the focus here in a few minutes. So let me go here forward. So basically we're a national center, and we have the goals of working with both in microscopy and microanalysis. I think remember that, I'll come back to that several times, not just images, but microanalysis, academic and industrial. We didn't start that way. We knew we would do a little bit, but it's expanded much, much more than we ever imagined. And then we're a multi-user, multidisciplinary. So I liked one of the other speakers earlier talking about how they work also with companies. I think it's a huge advantage to do that now. It's sort of a win-win situation for companies and research and development and other things I'll come to. So we provide services, research and development in the center, innovation, and then now we're doing more and more human resources training and career development. So the center, you can see the little yellow arrow there pointing to the center. It's in a very isolated area of the campus. The campus is rather large. It's 8 million square meters, over 8 million. We picked a spot that doesn't have any roads near it, no vibration, tested all over the campus. So it was specially built. The center was started as an idea in 2001, 2002. Everybody had broken microscopes, broken equipment, and so we went together, and it was physics and cell biology department, and then it became engineering, vet, medicine, physics, chemistry. Everybody came on the project, and when we submitted the project, we had 13, I just looked to be sure, 13 different institutes that participated. So we originally just got one scanning electron microscope and one transmission scope. We planned to put it in the Biological Institute, didn't pass, so we ended up building this special building with controlled vibration, low magnetic field, thermally stable environment, and of course, uninterrupted energy supply. You can see here on the bottom photo, it's sort of the L-shaped building, the two photos there you can see, but if you look at the next slide here, this is a layout. It's a little over 1,000 square meters. So we have 13 salas for microscopes. We have really nice designs that we went all over the world, traveled several times to Europe, to different places, different labs, to Japan. Some people went to Australia. So we checked out 20 or 30 different microscopy centers, and we came with our plan. So then the center was built with I don't remember how many hundreds of meetings with engineers and architects at the university. So we finally came up with a plan, and the plan has now been used in several other places, and it kind of got known through that avenue also to industry, kind of heard about we were building the center. So you can see some of the microscopes at the bottom there. So we have transmission, a scanning, and then a STM. A couple of companies donated, like this bottom was an Omicron microscope that came from Hewlett-Packard. They donated it from Palo Alto in California, gave us this. It's $6 million worth of microscope. Before I leave this, if you notice here, we have that wing where the microscopes are. We have preparation labs and place for people. And then we have also this annex. Sorry, I didn't change these slides to the English version, but in any case, you can see that. And so we have a lot of training programs that we go, and we have modular programs. It's constantly busy, so we have still 2 workshops this year. So very, very busy place. This is a list of the equipment that we have in microscopes. First thing you'll notice at the bottom, and then we do have 2 microscopes, a very nice fluorescence scope and a polarization scope, but almost all of the light microscopes are, well, I'm not going to return it, they're back in the Institute of Biological Sciences. So we have all of this great scopes, and again, I'll revert to what I said earlier. Every one of them has some sort of detector. So it's microanalysis, EDS, EELS, other methods that we can do detection. It's roughly I have a few more. I'll show you here some other ones. So counting these new equipments or specialized equipments, we have about 60 million reais of equipment at the moment. This is our latest edition. This just got installed a week ago. And so now we'll be doing 3D volume EM both with biological material, and also there's a demand in materials. So people that work on different synthetic materials or composites, they want to use this. So on both sides, we always have to look for both types of applications. We just purchased this microscope. Will be arriving in a couple of months. We do have cryo-EM capabilities, but we'll be only intermediate level, which is okay for us. We do lots and lots of liposomes and things I'll talk about in a minute, so this will be good for us. And then lastly, we always are investing in what can we use to push science forward. I think this is going to make a huge, huge difference in both materials. We've already needed this for several years. It's really good to do lithium analysis, which is hard to do with any other microscopic method. The EDS doesn't work. So this will be very, very good for us to have this TOS SIMS, but it's also now really exploded in pharmaceuticals and in biological analysis. I don't have time to talk here today about those. So the center, we have, again, I apologize, I do have this in English. I mixed up something somewhere, but so we have a council of directors council, and we have a technical coordination. And so we have these different people that are from different places that are on those two groups, some of them in both. And so we have a good distribution of people that understand the microscopes. Each of the microscopes has a person that's responsible for it. And so they are the experts. Again, I use a model that we have someone that's excellent from the physics department, exact scientists here. And so those people that do like atomic force, excellent person that everybody talks to him before they really start using the equipment. We have the bottom is the imaging scientists, the technical staff. And so that first column over there are several people that you see that have a PhD, doctor in this case, or masters in the second. And so these people have worked for years already on their programs. Most of them are either engineering or physics. Have a few now, 2 biologists in that group. And so they're experts and they know. So these guys are responsible, and they're what I will refer to here as level 1. In a minute you'll see that. So they're very well trained. They're way above average in their knowledge of what these microscopes are capable of. Many of them have worked in companies during their PhDs or masters, so that's one link that we have to all the companies that came back in. And then the other people here are other levels, but we usually, at the moment, we have 36 people in the center, so always new students, postdocs, people coming, leaving, so it's a turnover. I will mention, too, here that the doctor, the PhD, and the master students, they've taken it upon themselves. So already for several years, we've had modular teaching, mainly for materials. So we have companies that want short training how to use their microscopes. They don't have any idea. The list you'll see in a minute, but sometimes they come and so they do training with us. We do modular training, and that's been going for some time. Now we have this developed. I have mentioned the other day, so we're doing everything in Portuguese again because we found that there's a huge demand for these basic training in Portuguese, but will all be auto-translated into English on our YouTube and everything else. So here we have the list of people, and I just want to show this. It's important if you work with companies that you can't have somebody gone on vacation and you can't do something. So these, what I said, level 1, so we have level 1, level 2, and level 3. Won't go through the whole thing here, but we're always sure that our table, this is a little bit, I need to update this also, but we always have at least 3 people per microscope that have been trained. Don't have time here, but if you work with companies, you have to have a clear hierarchy and who's responsible to what and how communications occurs. That's a huge, we discovered the hard way that we didn't have this good communication, so you need to have excellent communication, knowing who's doing what, who's responsible where. If you look at the numbers of users that we've had, so we have like essentially 13% are from companies, empresas here, 43% with the university itself, and then 44% with others. It's growing constantly. We were inaugurated in 2006, so it took about 4 or 5 years just to get everything set up and trained and running properly. And we did have a few users at first, but then you can see that it's really grown, and now we've actually have more from outside of our university because we've become a national center, so FINEPI. So we have a lot of people coming from all over South America using our center. Active projects, just quickly here, it kind of went down during COVID, coming back up, and I don't have the numbers here. The person is on leave at the moment, so she has all my numbers. But in any case, I think this year we'll probably be in the range of 220 active projects this year. So here's the points with the companies. You can see here we have, as I said earlier, a lot of mining-related work. Then based on that too, you can see other things that are materials that are linked to that, alloys and other things. We do mechanico, so we do a lot of, can't say much about it, we do a lot of work with Fiat, so different iron alloys for their engines. Other things here, so electronic and gas, we have a big battery research, and about 18% of that goes to biological companies. So in the center, everybody pays. Even me as director or vice director, I have to pay. So everybody pays. I'll come back to that in a minute, but we have other, obviously, we have FINEPI, other FAPIMIGI, other grants that we've had, and so there's a constant submission of proposals, trying to find money for everything. I'm in the process of writing 3 proposals at the moment, so that's why I have gray hair. So here, if we go back to those life sciences, over there you can see on the far left bottom, we have life science, so environmental sciences, biopsies, diagnostics, biomedical equipment. So we really, now I'm actually actively looking for these companies to get. So we have a list here. I don't have time to go into them, but they are growing, and we're trying to go from 18%. Our goal is 30% in the next 2 years. So there's a big influx of these companies. Funding, I'm going to have to jump over this quickly per time, but we have various sources. The total budget that we go through in dollars per year, it's a little bit outdated, but gives you an idea. So we're in 1 million, a little over 1 million total budget. And then it fell during COVID. And then on personnel, if you look, that's where you spend most of your money. So how do you pay for that personnel? So that's where the companies come in. Remember I said that we had this 35 people, so 14 of those people are paid by university and permanent funds. All the rest of them, we have to find grants or money, and the money mainly comes from companies. So if you look at our website, we have all of these little drop-down menus, and then if you look at the one that's marked in the arrow, the table of cost, we charge a certain amount for UFMG, our university, but then we charge twice the amount mainly for other universities. And then for companies, it's usually somewhere between 4 and 6 times. We do extremely deep studies of the instruments and what's used and how much, so we know exactly how much are spent to do down to the buffers that you use for preparation of samples. So we did this very, very deep analysis, and we redo that, counting the depreciation of the microscope, which most people don't do. So we now do that. So that takes also, don't have time, but we have a big system of controlling all of the documents, because you can't, when you have 40,000 samples coming through a center a year, you have to control where they are, whether there are problems. So we have a very excellent system of controlling all of this, a laboratory information management system, which we built. I'm going to close here quickly with just 3 or 4 more slides just to show that the companies, the very last line in blue there, you can see that they do publish papers. It started coming up, and then it went back down again for COVID. I don't know. I hope it comes back up. So we have those people. The center itself had a high point of 191 publications per year total. Don't have time to discuss too much here, but just in the bottom there, you can see the 2 green and kind of gold or orange colored lines. Those are, green is life sciences publications, so 44. And then the other ones, multi-user, so have a lot of with physics and other people. These are some of those publications that come out, so they're in Nature, so we do have a high quality of publication. These are a couple of, I mentioned these to a couple of people, so it's innovation, so these are new methods that we do with twisted, probing twistonics, with tears, tip-enhanced Raman spectroscopy, and the other on the other side here is scanning microwave impedance microscopy, so it's completely, not completely new, but new methods of testing materials. Both of these have spun off companies, and so there are also patents involved with this, so we've done fairly well with that. And then the last slide here is we do have a meeting coming up soon. So in October, it will be high-resolution microscopy. It'll be very interesting, and I hope to see all of you there.